Hello folks, and welcome to this introduction to redox reactions. By the end of this lesson, you should be able to identify a redox reaction, deduce the oxidation numbers for all elements in a redox reaction, and identify oxidizing agents and reducing agents in a redox reaction. So, you probably, throughout your life, have heard of oxidation in some context or another, even if you haven't really heard of reduction. So oxidation you probably have heard of related to food. You have these oxidants and they are terrible for you and they age you, and you should eat all these antioxidants to prevent aging and to keep you healthy, and so on and so forth. So there is something to it in that oxidation can cause damage to chemicals and so on and so forth, but at the chemistry level that we are learning, oxidation is a type of reaction. Now the funny thing is, oxidation is not a reaction that can happen on its own. Anytime you have oxidation happening, reduction is going to be happening at the same time. They're like two sides of a coin where you can't really have one without the other. Now, while you can think of oxidation, or you might think of oxidation as you're taking something and you're adding oxygen to it, and so as a result, reduction is probably you're taking oxygen out of something, that sort of holds true, but that's not the only way that oxidation happens either. More commonly, when oxidation is happening, something is losing electrons. And with reduction, something will be gaining electrons when all of this is happening. Now, as we move on through this lesson, a really important part of everything that you're going to do in this unit and any topic related to it is remembering which one is oxidation and which one is reduction. So, in terms of the oxygens, sometimes that can be helpful, but a lot of these reactions are not actually going to have oxygen in them. So we're going to be remembering this based on electrons. There is a particular mnemonic that I like using to remember this, and trust me, I use this every single time I have to think about oxidation and reduction, because it's one of those weird things that I can't remember, and this is that mnemonic. So here it is. Leo says grr. Leo, loss of electrons is oxidation, gain of electrons is reduction. There are other mnemonics like oil rig and so on and so forth, but this one, I like this one better. Leo says grr. So make sure you find a way that you can remember these that works for you as we move on. Alright, to confuse matters a little bit more, we have what are called oxidizing agents and reducing agents. Oxidizing agents are something that will cause something else to oxidize. So it causes oxidation in something else. And a reducing agent is going to be something that causes reduction in something else. So since an oxidizing agent is causing something else to oxidize, that means it itself is going to end up being reduced. And vice versa. A reducing agent causes something else to reduce, so it itself becomes oxidized. So find a way to remember this. They are straightforward in a way, but also not, and so this is one of those things that can be confusing. So here I'm going to use oxygen to hopefully help out in these matters. Now, we have this iron, and this iron, when it became iron oxide, it has gained oxygens. So, iron has been oxidized. Now, when it became oxidized, it has now, iron itself, is a reducing agent. On the flip side, this oxygen made iron be oxidized. And so it is an oxidizing agent. So as an oxidizing agent, it itself ended up becoming reduced. Okay. So oxygen being an oxidizing agent is probably simple enough. Let's see what happens though in reactions, in redox reactions, where you don't have oxygen involved, where we have to keep track of the electrons. For that, we're going to use oxidation numbers. Now, if we're being really, really technical, oxidation numbers are a bunch of it's a bunch of pretending. So you're going to take the elements inside, all of the atoms inside a compound, and you're going to assign numbers to them. Now the pretend part is, even if it's not an ionic compound, even if it's a molecular compound, you're going to pretend it's an ionic compound and they did an electron transfer. And then based on these numbers that you get, you can figure out what has happened in terms of the electrons in a reaction in general. So once again, these oxidation numbers are based on the idea that you're pretending that everything is an ionic compound and everything has transferred electrons, regardless if actual electron transfer has happened or not. So some of the oxidation numbers are going to just look like charges of ions, because if you have an ionic compound, that's basically what it is. It's more pretend when you have covalently bound things. So these are the steps to determining oxidation numbers. I want you to write them down for now. I'm not going to explain them right now. I'm going to use some examples to explain this. Alright, here we have a few examples. First thing that you need to know is that whatever charge your overall species has, you are going to, when you add all of your oxidation numbers up and you add the totals of all of the elements that you have, the numbers of everything that you have, the total is going to be equal to whatever charge you have on that species. So in the case of water, we're going to assign oxidation numbers, and when we add them all together, it's going to be equal to 0. Now this isn't an ionic compound, so we are going to not worry about splitting it into different ions, and then we're going to keep on going from that. You figure out which one is the more electronegative element, which in this case is oxygen. So from here, for oxygen, we are going to assign the oxidation number by figuring out how many electrons would I need to add to make that octet in the valence shell. For oxygen, it has 6 valence electrons. You would need to add 2 electrons. So the oxidation number for oxygen is going to be -2. For hydrogen, yes, it's not in a compound with a metal, so you can sort of assume that it's going to be +1, and in this case it is, but you would figure out your hydrogen being +1 because your oxygen is -2. That means you have an overall +2 from the hydrogens. You have 2 of them, so each one is +1. Now when it comes to oxidation numbers, it is very important to write the charge and the number in the correct order. You must always write the charge first and then the number after it. If you do not write it in this order, that is not correct. Also, this is one of the rare cases in chemistry in general where you actually will write ones. If you have a +1 or -1 oxidation number, you are actually going to write those numbers. Alright, for our ammonium nitrate, we're going to first take this ionic compound and split it into its ions. And then we're going to treat these ions separately. So in this particular one, you have your nitrogen and your hydrogen. From here, you can say, oh, hydrogen is +1 because it's not with a metal, but also based on the fact that nitrogen is a more electronegative element. Nitrogen, 5 valence electrons, you need 3 more electrons to fill up that octet. And as a result, it will turn out that this is supposed to be +1 anyways, because you have a -3 from here. You have 4 of these hydrogens, but the overall ion does have a +1 charge. So each of these is going to be +1. That will give you +4, -3 plus 4, and then you get your +1 overall for this. And then for your nitrate ion, your oxygen is going to be -2, since that is the more electronegative element. Now from here, you have 3 oxygens, so you have an overall -6 from that oxygen. You know that the overall charge is going to be -1 because that's the charge that you have. So that means your nitrogen had to have +5. You only have 1 of them, and so that's how you get your +5. It's going to look sort of familiar to when you were doing all of your nomenclature last year and you had your multivalent elements, figuring out what charge those were. Same sort of idea there. For this last example, we have something that has 3 oxygens, so all of those oxygens are going to have the same oxidation number. The overall charge is 0, so every single one of them has to be 0. There you go. Now, coming back to this for just a moment, do note that even within the same compound, you can have the same element having different oxidation numbers. Because again, if you have ions in there, you're going to split the ions, and then what atoms you have in there, what oxidation numbers they have, is going to depend on what it is around. So in that case, let's go back to the whole what is oxidized in a reaction, what is reduced thing. So in this particular reaction, the first thing that you want to do is assign oxidation numbers to every element that's in here. After you do that, take a look at what's in your reactants and what's in your products and figure out what things have changed. So here you're probably going to see that all of your oxygens have the oxidation number of -2. Nothing has changed from reactants to products. Your iron, however, has changed, and your carbon has also changed. Now, your iron has gone from +2 to 0. So if that's the case, what it has happened to it is it has become more negative. Now, if your oxidation number is more negative, that means you've gained electrons. And if it has gained electrons, it has become reduced. On the other hand, your carbon has become more positive, which means that it has lost electrons, and therefore it was oxidized. Now, a little bit more terminology related stuff. When you are being asked for the oxidized species, yes, from here we know that the carbon is the element that's become oxidized, but when it's asking for the species, it is asking for the compound itself. So the carbon monoxide is the species that was oxidized. And so, following that same sort of logic, your reduced species is your iron 2 oxide. Be careful to read your questions carefully. Sometimes it's going to ask for the species, sometimes it will ask for the element or the atom, the specific atom, so make sure your answer is appropriate to that. Now to answer the next bit, which one is the oxidizing agent? Remember, the oxidizing agent, it itself is reduced. So our oxidizing agent in this case is your iron 2 oxide. Your reducing agent, it itself would be oxidized, so it is the carbon monoxide. Right. I suggest you chew on this a little bit. Let me know if you're having a little bit of trouble with this. But otherwise, I'll see you next time.